This is Algebra Lesson 2.5, Solving for Variables. So in this lesson, we're going to do all of the things that we've already learned in earlier lessons, solving one-step, two-step, and so on, problems, but it's a little different because we're no longer trying to get a numerical answer. Our answer will actually be an expression or an equation for a variable in terms of another variable or other variables. So we're still going to be solving. So we talked about solving using PEMDAS, but when we're solving, we work our way backwards. We undo the addition and subtraction first. We undo the multiplication and division next. We won't have any exponents, but then parentheses come after that. So let's start with this first one here. I have 2x minus 4y equals 8. And if I want to solve for x, I need to undo any additions or subtractions to get that x term alone. So I see a minus 4y. I'm going to undo that with a plus 4y. So the 2x is unchanged. Minus 4y and plus 4y is 0, so he's gone. And on the right side, you might be tempted to say 8 plus 4y. Well, that's 12y, but remember, those are not like terms. They actually stay as two separate pieces. And it doesn't really matter which one comes first, the 4y or the 8, but conventionally we put the variables in alphabetical order and the constants after that. So we undid our add subtract. We undid our subtraction with an addition. Now we're going to undo our multiply divide. We have 2x, which is the same as 2 times x, and to undo times we use divide. We're going to divide both sides of this equation by 2. So 2 divided by 2 is the invisible 1. Those eliminate. And on the right side of the equation, we're going to divide all of our coefficients by 2. So 4y divided by 2 is 2y, plus stays plus. 8 divided by 2 is 4, and that's that. Letter B says x over 5 minus y equals z, and our goal is to solve for x. So we're again going to undo any addition and subtractions to get everything we can, all the other terms away from the x term, and then we'll use multiply divide to isolate the variable. So we're going to get rid of the minus y by doing a plus y. X over 5 remains. Minus y and plus y make 0, so they are gone. Z plus y, we're going to write alphabetically. Y plus z, they are separate terms. They stay separate. We undid our add subtract. Now we need to undo our multiply divide. I see x divided by 5. We're going to undo that division by multiplying. And we're going to make sure we multiply both sides of our equation by 5. But it's important to multiply the entire side by 5. So I'm going to put that expression in parentheses before I keep going. So 5 over 5 is the invisible 1. Those eliminate. On the right side, we're going to distribute. 5 times y is 5y. 5 times z is 5z, and plus stays plus. Letter B says the formula for the area of the trapezoid with bases B1 and B2 and height h is given. A equals the sum of B1 and B2 times h over 2. Letter A says solve for h. So we're still going to work our PEMDAS backwards. We're going to start by undoing any addition and subtraction. But the problem is the only addition that I see is actually inside the parentheses, and parentheses comes last. So we have no add subtract to do. Our next step then is to look at the multiply divides. So I'm going to rewrite this so that I can see it a little easier. We're going to start by undoing this division here. We're going to multiply both sides by 2. Now our goal is to isolate h. We want to keep h right where it is and get rid of everything else. So this is h times something. We are going to divide by that something so that that eliminates and h stays right where it is. So h equals, whatever we divide on one side, we have to divide the exact same thing on the other side. So that's a little crowded. I'm going to go over here. H equals 2a over b1 plus b2. And that's it. So now we're going to solve for b2. A equals b1 plus b2 times h over 2. So we're trying to solve for b2. Our first step is the same. We don't have any adds and subtracts outside the parentheses, so we're going to start by multiplying both sides by 2. That is 2a equals b1 plus b2 times h. So now we're trying to isolate the b2, get rid of everything else. We're going to get rid of the h. We're going to undo the times h with a divide by h. 2a over h equals, I no longer need to write the parentheses because I have everything outside of the parentheses gone. So we skipped add subtract because we didn't have any of those. We undid the multiply divide, and now we're to the parentheses, so we're going to basically cycle back and start over again. Now we're going to undo the addition and subtraction. Since we have a plus in there, we are going to minus, and I'm sorry that I'm taking up this space down here, but I don't really have an option. We're going to subtract b1 from both sides. So that leaves us with b2 on the right side, and on the left side we have 2a over h minus base 1. Example C says, the formula A equals 46C gives the floor area A in square meters that can be wired using C circuits. Solve for C. So this is a simple one-step equation. I have A equals 46C, and my goal is to get C by itself. I'm going to divide both sides of the equation by 46. And then we get C equals A over 46. Letter B, if a room in 322 square meters, how many circuits are required to wire this room? We know how many square meters we have. We know the area, so we're going to just substitute that in for the A of this equation. 322 divided by 46. And if we do 322 divided by 46, I get 7. We need 7 circuits to wire this room. If there are 3 circuits available, what is the largest room you could wire? So now we know C. So I'm actually going to go right back to our original equation. If we're trying to find the area, we just need to do 46 times 3. 46 times 3 is 138. And that will be square meters. Okay, that is it for the exercises, or for the examples. Please let me know if you have any questions.